Electrical Automation and Robotics Technology is the name of a 2-year degree program at Utah Valley University. I learned more in this program than in any other education environment I've ever been in. The method is 1 hour of class at 7 a.m. followed by 4 hours of laboratory experiments and measurement backing up the information presented. We students have to connect the wires and take measurements, which means we have to understand what is what to get the experiment to work and get the correct readings and answers. Electricity and magnetism make possible the light relays, motors, and electronics now taken for granted in everyday life. Relay logic was the first control method explored by experimenters back when mechanical solutions were the only possibility. The name was modified and ladder logic is its pictorial successor. Relays can facilitate logic just like transistors, only slower and with higher power requirements. There are multiple layers and mediums of representation and resolution which humans employ to represent earthly implementations and acts. Electrical automation and robotics technology is the process of using electricity and technology to do work. Power is distributed from generation facilities at 60 Hz in 3 phases. 3-phase motors are the most popular motors for industrial factories due to their low maintenance and longevity and reliability. Let's explore a few. The blueprint schematic is a classic modern engineer scientist's secret storage medium. The play script is a theater playwright's, a scene is to editors, a song to musicians, and accounts for businessmen. The YouTube video, tweet, and internet media worldwide digital production levels are so high they would blow Gutenberg to Mars. This is the new battleground of ideas. I'll use ladder logic to explain as much as I can about how things work. Resolution and level of zoom are perspective tools. Allowing observation and data collection is required to predict an outcome. Design a traffic light to do exactly the same thing every time it operates, no exceptions. This is a low-resolution outcome request. A ladder logic diagram of the intersection light system increases the resolution as part of the design stage. Ladder logic allows the engineer to determine if it is theoretically possible to control such a system. Once the representative logic is confirmed as viable, the physical implementation is next to consider. This simple light has to have all of its parts created somewhere, somehow, and have to be purchased and arrive at the destination site with someone or something able to assemble their parts into the final configuration. Hardware and layout stage has a list of components, suppliers, cost, physical layout, and ship time. In the lab, we just use gloves and alligator clips as everything needs to be put away at the end of the day, so our constraints are not the same as would a company supplying a product or fixing its factory line. Recognizing the complexity of the supply chain from which products may be built, one understands the need to be able to zoom out to see the whole picture, and also to be able to zoom in to solve a specification problem at high resolution. Understanding how and when to increase the resolution, zoom in or zoom out, to ensure the desired outcome will result is key. The Earth is the largest reasonable social scale to zoom out, since humans can still only inhabit the Earth and will do so indefinitely, even when Elon goes to Mars. The individual is the smallest reasonable social resolution for human decision-making. Though mapping the observable universe at the largest scale and understanding cells, DNA, molecules, atoms, electrons, down to the highest observable resolution, Planck's, will need to be more fully researched and understood. These are the min and max resolutions of the physical universe and the human social universe. Different power requirements for different markets. Industry has 3-phase 60 Hz 480 volts, also known as 480, or 208 volts. US customers tend to get 240 split phase. All of these have special configurations allowing additional voltages. An example would be 480
can be turned into 120 done right, or you can use a transformer. That does limit your total power capability. Different outlets for different buyers' power needs. 480, 240, 208, 120 are the most common user connections in the United States. All of the above are 60 Hz in AC, however, 24 volt DC control is also a common finger-safe voltage for operators and control systems. 12 volts is used for vehicle systems in the United States and I think around the world generally, due to the 12 volt lead acid battery. 5 volts DC and 3.3 volts DC are USB and microcontroller voltage operations as well. This divides up the many electrical needs within the market, generally AC and DC. Power companies always supply AC and batteries always supply DC.